Hello my dear, I welcome you in this session of foundation course. So this is the second lecture of fluid kinematics. Okay, so in the previous lecture, that means previous lecture of fluid kinematics, we will discuss all the parts of related to the material derivative, what is the Eulerian approach, what is the Lagrangian approach, all the things, and what is the connectivity between these two. That means what is the connectivity between the Lagrangian approach and Eulerian approach. This we will already discussed. Now today we will discuss the some part of that conservation of mass. See my dear, if you know the very strongly of the mathematics in the vector calculus, so you can easily understand the fluid kinematics. So it's my humble request to revise your mathematics, particularly vector calculus. Okay. Now my dear, so what we have already studied, we already studied the del operator, that means this one. That means the del operator is your, we convert the Lagrangian description, that means this is your particle approach, to the Eulerian description, and this is your field approach. So this is your particle approach, this is your particle approach my dear, this is your particle approach, and this is your field approach. So if you convert the particle approach to the field approach, the essential tool is the material derivative, d by dt. What is the material derivative? We already discussed. So d by dt, so if you total differentiate of anything, either it is your scalar field or a vector field, this is essentially equal to the partial derivative with respect to time of the field plus v dot del of anything, v dot del of anything. So these are the essentially the material derivative. So yesterday we will already prove like that. This is your continuity equation, we already proved. That means dou rho by dou t, this plus divergence of rho into v. This is your continuity, and now my dear, this is a very strong equation. We already proved this equation with the help of material derivative concept, So my dear, we'll see the consequence of this one. We'll see the consequence of this material derivative. What is that, beta? See, if you take like that, this is very important. If you take like that, beta, that means d rho by dt, this is equal to minus of grade dot density. Okay, this is your equation. Now this equation have a physical significance. What is the physical significance of this equation? Please tell me, anyone. What is the physical significance of this one? See beta, what is this? This is what? This quantity. This quantity is what, beta? What is this quantity? What is this quantity, my dear? Okay, what is this quantity? This quantity is del dot mass flux. Del dot mass flux. Yes. Why? Because density into velocity per unit area is a mass flux. So this is what, beta? Mass flux. What is the mass flux? Mass per unit area. So density into volume. So what is the mass flux? See, density is what? Mass by volume. You know this thing? So if you write mass flux, so density divided by mass by area divided by volume by area. Okay, volume by area. So what is this one? so density. So if you write mass flux, so this is your mass flux. So m mass per unit area is equal to density volume by area. Yes or not? Volume by area. Okay. Now volume by area you can write as, this is your, if you write mass dot rate of, so m dot if you write, so this is volume dot. So rate of volume, volume flow rate divided by area is what? Velocity. Hi sir, volume, that means meter cube per second. Hi Sandeep, meter cube per second divided by meter square, that means meter per second, that means this is density into velocity, density into velocity. So this is your mass flux, this is your mass flux, this is your mass flux, and mass flux is what? Density into velocity. So my dear, change in density with respect to time is what? Del dot mass flux. So this is a mass flux. What is the consequence of this one? What is the consequence of this one? See my dear, this is what? This is your divergence. This is what? Divergence. This is your divergence. This is your divergence vector. So this is your, this combined, it is your divergence of mass flux. What is that? Divergence of mass flux, of mass flux. So this is your divergence of mass flux beta. Now why this is the negative? What is the consequence of this negative? We will discuss. I'll mind it, this is the new content part beta, you can never found anywhere, I am telling you. What is that? See, so what is the meaning of this one? What is the physical meaning? What is the physical statement of this one? See my dear, if you heat the any fluid, if you heated any point source, any fluid, so if you heated the fluid at any point, its density will reduce, yes or not? At that point the fluid density will reduce, that means this will be the negative, so it is negative. And now if it will be heated, so there must be a divergence of a streamline, that means at a point there must be a point where there is a divergence, that means streamline will be diverge. So if you are heating the system, if you are heating the fluid particles with the help of laser, so the density will reduce, that is your negative sign, plus positive of divergence of mass flux. So divergence of mass flux, that means mass flux at that point will diverge. So what is the meaning of this one? If someone asks you what is the physical statement of this one, please my dear, this is very important. If we heat up a fluid at a point, if you heat up a fluid at a point in a space, perhaps with a laser, its density, very important, its density drops, yes or not? Its density drops at that point, so it is a negative, density will drop at that point, so it is a negative, that is d rho by dt is negative. Now if it is negative, that means and the fluid diverge away from that point, that is del dot rho into V. Mass flux is positive, mind it beta. This is the physical consequence, this is the physical meaning of this equation. Okay, now my dear, we'll see that two situations, how to verify how to verify? Let's see the two situations. Very important, very, very important. Let's suppose a stationary fluid. That means we are heating in the two cases. First, in a stationary fluid. We are heating a stationary fluid. We are heating a stationary fluid, and the second case, heating, that means in a uniform flow. Uniform flow. We are hitting a uniform flow. What is the consequence of this one? Very important, I am telling you. Let's suppose we are hitting at a point. This is heat at a point. So if you hit the point, it will diverge all around. The streamline will diverge all around. Diverge all around. That means this is your hit at this point. That means we are hit at this point. This is your heat at this point. That means heat at this point. If you heat at this point, the diverging away in that point in space, and its density reduce. So minus, that means d rho by dt is equal to minus of mass flux. That means mass flux will be positive, upward. Now what is the condition in uniform flow? Very important. See my dear, if it is your hitting at this point, and let's suppose the flow is moving with a velocity v. Flow is moving with a velocity v, any velocity v. So if you are hitting at this point through a laser, locally the streamline will diverge. Yes. So locally the streamline will diverge. Locally streamline will diverge. But far from that point, the fluid is coming. In this direction, the fluid is coming. So let's suppose this fluid is coming. Let's suppose the fluid is coming. Let's suppose the fluid is coming, my dear. Let's suppose the fluid is coming. Let's suppose the fluid is coming. This fluid is coming. Okay. No problem. Let's suppose the fluid is coming with the velocity v, and here this streamline is coming. So there is a point. That is your stagnation point. It form a stagnation point. Yes or not? It form a stagnation point. Okay. So this is your stagnation point. This is your stagnation point. This is your stagnation point. Now, my dear, at this stagnation point, the fluid is not diverging. Why? Because divergence, it is what? It is your, at that point, it is your diverge positively, but at this point, there is a converge. So, my dear, so there must be a, okay, so there must be a diverge. So this fluid will diverge like that. At this fluid, there is stagnation. So flow, it is like that. So this fluid will be like that. At this point, it is like that. Okay. So it will intersect at this point. It will intersect at this point. So at this point, this is your streamline. This is your streamline, and here it is your stagnation point, and this is a point of source. Now, if you draw the another streamline, it is look like that. If you draw the another streamline, it is look like that. It is look like that. Now at this hitting point, this is your streamline. At this hitting point, this is your streamline. Okay, this is your streamline. At this point, it is like that. At this point, it is like that. So these all are the streamline. So my dear, this is your point of divergence, but here fluid will flow from left to right, left to right. So the stagnation point, it is at right. Fluid will flow from right to left, so stagnation point at a left. अब कुछ ना करें, आप गेट में फेल हो गए, कुछ ना करें, कुछ मत करिए, आराम से घूमने निकल जाओ कहीं पे. Don't do anything, please go and bother all around. Okay, mechanical world. If you are not qualified, stop the study, go around, घूमने निकल जाओ. Okay. So at this point, okay, so this is your heating. At this point, heat at this point, at this point, heat at this point, okay, heat at this point, okay, heat at this point. So this is your diverging. This is your diverging. Now here it is your stagnation point. So beta, it is your this fluid is coming, and this is going. So here it will be up, it will be converting. So it is not a diverging point, it is a stagnation point. So my dear, the stagnation point divergence is 0. That means no divergence. No divergence. It is clear? Please tell me. So this is the case when the fluid is static, stationary fluid, and then when the fluid is motion. So how the stagnation point arised and what is the point of source? This is a source where it will diverge. So this will be very clear. Someone asks you what is the divergence at the stagnation point. So sir, the divergence at the stagnation point is 0. Is 0. Why? Because at this point there is no divergence. It is a stagnation point. How to form a stagnation point? This is the concept. This is very important. I'm telling you, never you will find. So these are the this is your consequence of this equation. This is the consequence of this equation. Okay, my dear. Now let's suppose we have to perform next thing. What is that? What is the importance of this equation? These are the importance of the different of the del operator with the help of continuity equation. So what is that? Let's suppose take density constant. Let's suppose take density constant. You feel free ask any question, okay? Density constant. That means for the ideal gas, equation of a state, what is the equation of a state? PV equal to mRT. That means P is equal to density R2. That means P is equal to density RT. We are thinking like that, okay? Someone asks you, it is there. Someone asks you also, I will just tell you. That means density neither function of temperature and neither function of temperature and pressure. We are thinking like that, neither function of temperature and pressure. So my dear, if you write the continuity equation, that means del rho by del T is equal to minus del dot rho into velocity. This is a continuity equation. Now see the consequence, very important. How to write this equation? For in the vector form we can write like that, minus rho del dot V minus V dot del rho. We can write like that. If you split it, if you split it, these are the expletives, these are the separation. Now my dear, if the density constant, what is it? Del dot rho? Del dot rho, it is the function of x, y, z. So if the density is constant, that means this is 0. No, this is 0. This is 0. Why? Because this is 0. And also if the density is constant, this is 0. Del dot V is 0. That means if the density is constant, if density is constant, that means incompressible, very important. Density is constant, that means dou rho by dou T is equal to 0 and del rho is equal to 0. Then what is happening? Then this is very important. Then minus rho del dot V is equal to 0. Now, if you don't know how to expletive, you can leave the class. Okay, these are the basic calculus. Okay, so what is this meaning? That means del dot V is equal to 0. This is the condition for the density constant, that means incompressible fluid. This is proved. This is proved. And what is this one, beta? This is your rate of volumetric strain. This is your rate of volumetric strain. This is your rate of volumetric strain is 0. Rate of volumetric strain is 0. That means incompressible fluid, that is your incompressible fluid. Incompressible fluid. And my dear, in the incompressible fluid, streamline neither be created nor be destroyed. This is very important. So for the incompressible fluid, streamline neither be created nor be destroyed. Very important. These are the very high conceptual thing I am telling you, beta. You can never found this thing. So this is your volume del dot V is equal to 0. That is for the incompressible flow. Clear? Now, my dear, I have one numerical also. Ki application of that conservation of mass. What is that? See this equation. Okay, this is done. This is done. All these things done. Now this is one question to this one. Okay, please try to solve this one. This is one question, basic question. Please try to solve. A student says that this is very tough question. No, I am telling you this is very easy question. If you understand the continuity question, the nature of the continuity question, that is very important. Okay, consider a unidirectional flow. Unidirectional flow means that 1D flow. That means this is your 1D flow. 1D flow. Unidirectional flow. Unidirectional flow. That means 1D flow. One dimensional flow. Unidirectional flow. 1D flow with a velocity field. See, this is your field. This is your velocity field. This is your Lagrangian Eulerian approach, and that is the only function unidirectional. That means I cap. That means this velocity field, it is only u component of u in I direction, one component. Okay, where it is given u, that means u at x is equal to 0 and t, the value it is given 1. This value it is given. If the spatial homogeneous density field varies with time, that means homogeneous density, that means density doesn't vary with the position, only vary with the time. Only vary with the time. So density is the function of density is also now. So this density is a only function of time. That means this is your Lagrangian approach. Why? Because it is not depends upon the position. Okay, so this is your Lagrangian and this is your Eulerian. Okay, so density is this one. So value of velocity in this variation of density at x is equal to 2 and time is equal to 1 is what? That is the question. That is the question. So this density is varying density, but the variation of density only with respect to time. So if you take the general, if you take a general form, if you take the general form, my dear, if you take the general form, what is that? Continuity equation. Now, my dear, see, if you have this question, if you have in front of this question, let's suppose this is a GATE question in front, you are sitting in the examination hall, you are sitting in the examination hall. So, my dear, the first thing in our mind, how to solve this question. See, this is the velocity given, density given. The relationship between velocity and density, it is your continuity equation. So just apply the continuity equation in the form of differential form. So this is your continuity equation. What is the continuity equation in the differential form? d rho by dt, this is equal to del rho by del t plus divergence of mass flux. Divergence of mass flux. Always remember, divergence of mass flux. Change in density with respect to time plus divergence of mass flux. My dear, this density is for the particle. For the particle, and this is equal to the total derivative d rho by dt, and this rho is for the field, for field. This is for the field. This is a total derivative, material derivative, and this is for the particle. Now, if the density is, so how to explain this one? If we take this one, d rho by dt, how to write this one, beta? How to write this one? Dou by dou x into rho, or v vector in x direction is u, plus dou by dou y, rho v vector in y direction v, plus dou by dou z, v vector in z direction is omega. Clear? You can explain this one. Okay. Now, my dear, this is your one dimensional. That means it is given. What is given? What is given? V velocity field is equal to u xt I vector. That means the velocity field is in one direction. That means the component of velocity in y direction 0 and the component of velocity in z direction 0. So this is a 0, this term is 0, and this term is 0. Clear? Clear? Now, what is left then? That means this is like that. Okay? Okay. Now, so that means d rho by dt plus del dot u, and my dear, it says that, it is saying that the continuity equation. So this is, what is that? This is equal to 0 for the continuity equation. Yes, this is 0 for the continuity equation. This is 0 for the continuity equation. Yes, why? Because the total derivative d rho by dt is 0. Why? Because let us see this one. What is that? Del dot v vector is equal to 0. When it is 0? When it is 0? We'll already discuss. That means this is what? D rho by dt is equal to dou rho by dou t plus v dot del. V dot del. This is your V dot del, okay. V dot del into rho. This is your material derivative. This is your material derivative, okay. This is your material derivative. Now my dear, this says that density is the function of time. Yes, density is the function of time, and what is the continuous equation? D rho by dt is equal to dou rho by dou t is equal to d rho by dou rho by dou t plus divergence of a mass flux. This is what? This is what, beta? Divergence of a mass flux. Of mass flux. Of mass. Divergence of a mass flux. So divergence is equal to 0. That means this is 0. This side, so this is 0. Now what is the equation then? Dou rho by dou t plus u is density is the only function of time. Density is the only function of time. It is in the expression, it is showing. So density you have to take outside. Why? Because it not depends upon the x. So dou density dou u by dou x. This is equal to 0. This is the continuity equation for the given condition. For the given condition, this is the continuity equation for the given condition. Now you have a density, you have a velocity. Just explain it. Now so if you differentiate this one, this is your minus 1. Why? Because density is what is given density? Density is equal to 1 plus 0.2 e to the power minus t. Yes or not? This is given condition. So if you differentiate, so minus 1 into 0.2 e to the power minus t. This is done for this one, plus density is what? 1. This density 1 plus 0.2 e to the power minus t. And now u is there. Why? Because u, it is in the function of u x t, it is given. So if you write like that, dou u by, so u is the only u is the function of x and t. So keep it is at a partial, not total, okay. Dou, why? Because see, u is the function of x t. So if you differentiate, why? Because this is for the field. This is for the field, dou u, this is for the field, not for the particle. Very important, this things is very important. This is for the field. Why? Because this is a partially, this is for the field. So dou u by dou x is equal to 0. Clear na? Clear? Now from here you can take like that, dou u by dou x, dou u by dou x is what, beta? Dou u by dou x is equal to 0.2, it is visible, yes, 0.2 e to the power minus t divided by 1 plus 0.2 to the power e to the power minus t. Now it is a very simple, just you integrate it. This u is the, here it is a x, only x, so you have to integrate it. You can write dou u is equal to this constant, this time derivative into dx. Now if you integrate, so this is a u, and u is the function of x and t, and this is equal to this constant into x plus c. This is dotted is this one, x plus c. Now the condition it is given, what is the condition it is given, beta? The condition it is given, you have to find u at x is equal to 0 and t is equal to 1. So if x is equal to 0, if you put x is equal to 0, this all term is 0 and this is 1, it is given. This is 1. If you put x is equal to 0, so this value it is your 1. So this is 1 into this is 0 is equal to c. So what is the c value? C is equal to 1. C is equal to 1. We have a boundary condition, c is equal to 1. Now if once you have to c is equal to 1, so again you have to write this equation in this form. So what is that? now you have to write complete integration 0.2 e to the power minus t divided by 1 plus 0.2 e to the power minus t. Okay, and what is the x, what is the, this you have to find, okay, it is your x and t, no problem. So this your x, plus c is what? 1. Now we have to find what is the question it is given? You have to find x is equal to 2, t is equal to 1. That means we have to find at x is equal to 2, t is equal to 1. Put the value here, 0.2 e to the power minus 1 divided by 1 plus 0.2 e to the power minus 1, x is 2 plus 1. If we solve this one, this is your 1.137 meter per second. So my dear, if you don't know the nature of the continuity equation, if you don't know the nature of the continuity equation, you cannot solve this question. I am telling you. That's why all the things are very important. What is the continuity equation? What they tells that? What is the divergence? How to convert? What is the stagnation point? So many teachers don't know many things. Many don't know if there is a stagnation point. What is the divergence? Divergence is 0. Divergence is 0. Why? Because the stagnation point, the point that the fluid, it is at a rest point. That means it is at a point of a stagnation point. So there is no any case of divergence. Okay. Now this is done. Now my dear, we'll go to the next topic, that is your fluid acceleration. So you know all the things. Let's suppose my dear, this is the what? This is the what situation? This is what situation? Unsteady and non-uniform. This is the case. Why? Because, why it is a non-uniform? Why it is non-uniform? Why? Because the nozzle is converging, so each and every section, the velocity are differ. And you have to regulate this, there is a regulator. So accordingly, you have to increase the size. So if you increase the size, that means if you open the valve, increase the size. So if the increasing the size increase, the flow rate will change. So the flow rate will change with respect to the position and also with respect to time. So this is the case of my dear, this is the case of unsteady plus non-uniform. Now, if you take the change in the volume, let's suppose this is your control volume. It is like that. It is a control volume. Let's suppose this is your control volume. This is your control volume. This control volume, it is at x. So this is your x plus delta x. Okay, so there is in, there is exit. So my dear, if you take the change of the velocity within that one, if you find the delta v, so if you find the delta v, this is your mathematics, derivative mathematics. So this change in volume, the change in velocity, why? Because this is your unsteady and uniform. So first effect is the unsteady effect, second effect is the non-uniform effect. So change in volume, there are two effects. First one is the partial. Why? Because this is we have the fixed the control volume. That means there is a field approach. So this is for the field. This is for the field. This is for the field. So dou v by dou t into delta t. The delta t, the time it will take from this to this one is delta t, plus dou v by dou x, this is your x direction, this is your direction of x. So dou v by dou x is delta x. Now what is the change of velocity with respect to time? That means this is your unsteady. Change of velocity with respect to position, that means your non-uniform. Both are combined. Now, since delta x, this delta x is a distance covered in delta t, that means the fluid which is trying to enter and it will exit, how much the distance it will cover? It will cover the distance of delta x. Delta x distance will cover at what time? Delta t. Delta t. Then acceleration of the fluid particle becomes. Why? Because you have a delta x and you have a delta t, so there must be acceleration. So what is the acceleration? You have to divide this delta v by delta t. So if you divide by delta v by delta t, so delta v by delta t is what? Acceleration. Delta v by dou v by dou t, delta t cancel, plus dou v by dou x, and now delta x by delta t. So if you divide, what is that? So if you divide first term, so first term divide, so first term, for first term, dou v by dou t plus this is your dou v by dou x into delta x by delta t, yes or not? Now put the limit. If you put the limit delta t tends to 0, why we are putting the limit? Why? Because beta, the fluid is continuous deforming. So, and the deformation, the time is, we are taking the very elemental part, very short time. So, we have to take the delta t tends to 0. So, delta v by delta t, dou v by dou t as it is, and if we put the limit in this one, that means here we have to write delta t tends to 0, delta t tends to 0 here we have to write delta t tends to 0. So delta t tends to 0, this is your dx by dt. This is your dx by dt. So see, this is your dx by dt after putting the limit. So acceleration is here. Now beta, this acceleration, this is essentially the total derivative. Why? Because the derivation with respect to time and with respect to position. So that is your total derivative. So dou v by dou. So the acceleration, this is acceleration for what? This is the acceleration of a fluid particle, and this is v for the field. So this is a Lagrangian and this is your Eulerian. So the del operator, and this acceleration is what? How to write? This acceleration is what beta? dv by dt is equal to, this is the acceleration, and this acceleration is what? Dou v by dou t. This is very important. What is the difference between these two? What is the difference between these two? Please tell me. What is the difference between? This is for the, please tell me beta, please tell me. I know that very less number. So this v for the field, v for the particle which are moving in this direction, and this v for the field. So this v for the field. So this acceleration a is for what? This acceleration a for the particle. This acceleration a for the particle. So a for the particle is equal to d for the field dt, v into this dx by dt is what? V. So del by dt. So the acceleration of this fluid particles when it is flowing from this position to this position is what? Dou v by dou t plus v dou v by dou x. The first component, yes, after that, okay, no problem. Rahul, thank you beta, thank you. Thank you for encouraging. Yes, 2 people watching, okay. So dou v by dou t, that is your local acceleration. Rahul, please tell me what is the material derivative? You know, Rahul, what is the material derivative? Please reply in the comment. Dou v by dou t is your local acceleration and this is your convective acceleration. Why? Because this is your local, that means this is your unsteadiness effect. That means this is also called temporal. This is also called temporal, and this is also called convective acceleration. Rahul, what is the material derivative beta? Okay, so this is your acceleration of the fluid particle. Now if we take the acceleration in the 3 dimension, why? Because this is 1D, yes or not? This is your 1 dimensional fluid is flowing. But in generally we have to take the 3 dimension. So 3 dimensional, let's suppose there is a x axis, y axis and z axis, and these are the streamlines of the fluid particle. These are the streamlines, let's suppose. Now we are taking a control volume. We are taking a control volume, and in that one there is a fluid particle is there. This fluid particle have a velocity v, and this v velocity have a 3 component: x component, y component, z component. That means this v, it is your ui, plus Vj plus omega k. Ha Rahul, please tell me what is the material derivative? Rahul, I am waiting. So see my dear, so this V, it is your x, y, z into t and t. So this is your field. So this is what beta? This is for the Lagrange Eulerian description. This is for the Eulerian description. Why? Because we have a control volume. We are analyzing the control volume. So for the control volume, the velocity x, y, z, t, and the velocity component u, it is in I direction, v, it is in z direction, omega, it is in k direction. Okay. So if we find the acceleration, so this is your dou v by dou t. This is total derivative. So this total derivative is one of the temporal component and other one is the convective component. So if you differentiate this dv by dt plus that differences, so this is your time respective. So this is at any location. That means you have fixed the camera. That means this is at x, y, z. So we have to take a partial derivative. Now this dou v by dou t, now v is itself a function of x, so we have to differentiate with respect to partially. Why? Because this is the function of t also, so we have to partial differentiation. Now the x is not a function of t, v is the function of x and t, v is the function of y and t, v is the function of z and t, but x is the only function of t. So x is the only function of t, y is the only function of t, z is the only function of t. That is your Lagrangian approach. So we have to take ordinary differentiation. So dx by dt plus dou v by dou y dy by dt plus dou u by dou z dz by dt. Okay, so this is your acceleration term. Now my dear, if this is your acceleration vector, a vector. Now this is your total derivative. Now this one is your local and this term is your convective. This term is convective. So how to write this one? You can write like also, okay, sir, what is this? What is this beta? What is this? This is your what? If you take v del by del x, u v del by del y, omega del by del z, and v, this is your field. So this is for the field. This is for the field. So if you take a common, so this is what? V vector dot del dot v. So this is what beta? Del dot v, del dot v, del dot v into v vector. Okay, na? So this is like that. Okay. So this is your acceleration. Now if you take the acceleration in x direction, put v, it is in x direction. 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 If you find y direction, put this v, it is in y direction. That means u, this y direction, the velocity is u, v, this z direction velocity is omega, and this x direction velocity is u. Okay. So this dou v by dou t plus u dou v by dou x plus v dou v by dou y plus omega. Like that, if you take a z direction, put v here omega, put v here omega, put v here omega, put v here omega. So these are the acceleration component. Now if you find the total, you just square root. Just square root a vector, if you find just square root of a x square plus a y square plus a z square. This is the acceleration, total acceleration, net acceleration of the particles. Okay, so these are the analysis of a three-dimensional flow. Now my dear, this is one question, is a very beautiful question. Please try to solve this question, beta. I am telling you what is that. See, please try to solve this question. What is that? The velocity of a gas particle, this is the velocity of a gas particle, gas particles flowing along a center of the pipe, okay. In a figure, it is defined as x is greater than equal to 1 meter. That means this is your x and this is your x is equal to 1 meter. The particle is defined. The particle is defined by the velocity field. See, this is your velocity field, and this field is the function of x and t. That means this velocity field v is the function of x and t. So essentially this is your Eulerian approach. This is your Eulerian things. Now my dear, see, if you think that, okay, sir, the velocity, it is if you take the unit t by second, that means meter by second. it is here, it is a meter. So you think that this is some mistake. No, it is not a mistake. It is not a mistake. Here something constant is there which is not showing, and that constant, the unit, it is your second square per meter square. So if you write here any constant is there, and that constant unit, this is a constant, let's suppose, and this unit, it is your second square by meter square. Okay, so if you multiply meter, this meter by second, so this meter cancel, this second cancel, so it is already meter per second. Okay, it is like that. This is meter per second, na? So this k, it is your, if you find this velocity, so velocity it is yes, so it is your second square per meter square, and it is your unit, velocity unit, meter per second. Okay, na? Yeah, it is like that, constant meter square per second square, and what is the unit of what is the unit of velocity? Meter per second square per meter square. So what is the unit? So here what is the unit for this one? So that what is the unit of this one? Meter square per second square. Let's suppose k unit meter square per second square, and what is the t unit? Second by meter. So this meter cancel, this second cancel, so this is meter per second, this is meter per second. It is clear? This is meter per second. So here is constant, but constant is not given, so that student get confused here, and they are changing that. No sir, it is x by t. No, it is not like that. Okay, so there is must be constant. The constant unit, it is your meter square per second square, so that if you multiply with second by meter, it is already meter per second, it is coming. Okay, no problem. Now where t is in second, x is in the meter, t is in second, x, the particles at x is equal to 1 meter, when time t is equal to 0, that means particle at x is equal to 1 meter, where the time it is equal to 0. Now determine the velocity when the particle it is at 2 meter. So let's suppose the particle it is at 2 meter, what is the velocity at this point, and also determine the acceleration at 2 meter. Acceleration you have to find. So velocity and acceleration find. How to find, please? How to find, beta, please? Everyone try. Everyone try, my dear. How to find velocity? This is very important. How to find the velocity? Please find it. How to find the velocity? How to find? See. If you find the velocity, how to find the velocity? See, what is the velocity field it is here? What is the velocity field? V. Velocity field it is given, and this field it is a function of x and t. X and t, and this is given x by t by x. What is given? T by x meter per second. It is given. Yes, it is given. Now, so see my dear, if you find the velocity, so we have to find the velocity of a particle. See, determine the velocity at x is equal to 0, that means this particle velocity. So if you find the velocity of a particle, there must be a Lagrangian approach. So we have to find velocity of particle. Velocity of particle. So for the particle, that means Lagrangian approach. Lagrangian. And how to find the Lagrangian approach of velocity? You know that velocity of a particle in x direction, up, is equal to distance x by t. Yes or not? Yes or not? X by t. This is your velocity of a particle, but it is in gain t by x. So if you find the velocity, so this is your distance x. So if you find the distance, velocity, so here is a distance and time. So velocity of a particle in x direction, yeah, let's suppose v, it is given, na? V it is given, na? X direction. So v, velocity of a particle, What is the v? dx by dt. You know this? dx by dt. And this dx, but this velocity it is given how much? T by x. Clear na? If you strike this line, that is the very important. Why? Because this is your Lagrangian description. This is your Lagrangian. This is the velocity of a particle. This is the velocity of a particle. This is your particle. This is for the particle. Why? Because this is ordinary differentiation. So this is for the particle. This is for the particle. This is for the particle approach. So this is for the particle. Now my dear, this is t by x. Now if you integrate it, how much? 1, it is x. So if you take x, dx is equal to t dt. Now if you integrate at x is equal to 1 to x is equal to 2, at x is equal to 1, time equal to 0 to time is equal to t, any time t. We have to find any time t. T it is not given. So if we split it, this is x square by 2 minus 1 by 2, this is equal to t square by 2. So what is x here? X is equal to square root of t square plus 1. Yes or not? This is x in meter. Now they are asking that what is the velocity at x is equal to 2. So at x is equal to 2, what is the time? First require the time. So at x is equal to 2 meter, what is the time? So put this value here, 2 square is equal to t square plus 1. So this is t square is equal to 3. So what is t? T is equal to square root of 1.732 second. This is your time. Time we will take from particle from point x is equal to point x is equal to 1 to point x is equal to 2. Now if you have a t, so put t and distance you have. So velocity v of a particle is equal to t is how much? 1.732 divided by x. X is how much? 2 meter. What is that? This velocity is 8.8. So my dear, this is a 0.866 meter per second. This is a velocity. Now how to find the acceleration then? How to find the acceleration then? This is the velocity. Now how to find the acceleration then? We know that acceleration. So we know that acceleration A is what? dv by dt is what beta? Please tell me. Dou v by dou t. Dou v by dou t plus. Dou v by dou t plus. If you find, this is your acceleration. So in any direction, let's suppose any direction. So v direction, v it is in direction, it is let's suppose x direction. This is x direction. So v. Now velocity in x direction, u dou v by dou x. Velocity in y direction, dou v by dou y. Velocity in z direction, dou v by dou z. Clear? This is the acceleration. This is your acceleration. This is your acceleration. Now my dear, this is one dimensional. This is one dimensional, only x direction. So this is 0. V component it is 0. Omega component it is 0. So this is 0. So what is the acceleration? A is equal to dou v by dou t plus u dou v by dou x. Okay. Now what is v here? V is equal to t by x. It is given. Put here. So the acceleration A, differentiating with respect to time, this is 1 by x plus u is what? U is the velocity, t by x, dou v by dou x. If you differentiate, see this one, v is equal to what? T x minus 1. So dou v by dou x, t kept outside, so t x minus 2 by minus 1. So this is what? Minus t by x square. Clear na? Now all value you have at x is equal to 2. So put 1 by 2 plus t is equal to how much? 1.732. 1.732 x is equal to 2 minus T 1.732 x is equal to 2 to the power 4. So if you find this one minus, okay, if you find this one square here it is a square. If you find this one, this is your 0.125 meter per second. This is a very good question. Clear? Okay, na? This is done. So I will stop here. Today we will discuss the conservation of mass. What is the application of the conservation of mass? So we'll stop here and then we announce something here. What is that, beta? This is the IMS features. What is that? If you're willing to join the GATE 2025-26, this is the IMS feature. What is that? In the IMS 8,000 plus hour live classes you have with a live interaction, theory book, exercise book, and in the exercise book, beta, 4,000 plus questions, okay? And that question is divided by level, level 1, level 2, level 3, level 3 like. Now, 12 personalized one-to-one mentorship and 130 online test with the video solution, okay? On video solution. And there is a very important feature. In this one, there is a video solution also. In the GATE question bank, there is a video solution also. If you are not able to understand the question, you can directly see the scanner. There is a QR code is there. Just scan that QR code. You can automatically watch the video on this corresponding question. Now, this is the very good things. That means you just must be joined today. This is a Telegram group. It is a free. That means if you join, what is the features? That means what the activity, the YouTube lectures, you have to go to the you have a frequent notification lecture PDF. What you have to today will learn that PDF lecture will upload on this Telegram group, and important updates related to where is the seminar, what is the webinar, all the things. Important PSUs and government notification time to time it will release, and expert session of important topic. There is any session is there, expert session will take update, and daily cues and many more. So don't miss that one. You can join immediately. It is have a zero cost, so you have get a notification. And my dear, if you want to know that such type of concept, why? Because what I'm discussing now, you can never find in any YouTube channel. I'm telling you, it will such like that. It is not a normal classes. It is a YouTube classes. So we will give the more and more effort. Okay, na? So please subscribe the IMS YouTube channel and also press the bell icon so that you get the notification time to time. Okay, beta. Thank you. Bye-bye.